Hey there and welcome. If you've ever looked at an app and thought, I wonder if I could build that, or just wanted to peek behind the curtain of the tech we use every single day, you are in exactly the right place. Today, we're basically drawing a map for the very first chapter of your coding adventure, and we're breaking it down into 13 key steps. Let's get started.
You're not the only one, trust me. That wall of text and weird symbols, it can look totally intimidating, almost like a foreign language. And, well, here's the secret. It is a language, but it's one that anyone can learn. The magic behind your favorite websites, your favorite games, it all starts with just a few core ideas that we're about to walk through.
So, to make this whole thing feel a bit more like an adventure, we've broken it down into 5 stages. First up, we'll answer the call to code. That's the big idea. Then we'll get your first toolkit, the essential gear. After that, we'll get into making things happen, writing your first program, and finally, we'll talk about the journey ahead.
You know the saying, every journey begins with a single step. And for a programmer, that very first step, it doesn't happen on a keyboard. It happens in your head. It's the idea. This is what we're calling the call to code, that moment you decide what it is you actually want to create.
See, programming isn't some kind of dark magic. Really, at its core, it's just a process of taking a thought, something like I want the app to show a picture of a dog, and then breaking that thought down into a super logical, step-by-step list of instructions that a computer can follow perfectly.
All right, so we've got our quest, our big idea. Now it's time to gear up. Just like a carpenter needs a hammer and a saw, a programmer needs a basic toolkit. And these are the fundamental building blocks you're going to find in pretty much any programming language you decide to pick up. I love this slide because it's such a great way to think about it. Learning to code is a lot like learning to speak a new language. In a spoken language, you have words, right? In programming, you have keywords. You have grammar. In code, we call that syntax. You put it all together to make sentences, or as we call them, statements. And eventually, you have a whole conversation, which is basically a program.
So let's talk about syntax. Syntax is literally just the grammar of your programming language. Think about it. If you misplace a comma in an email, it might look a little weird, but people will probably still get what you mean. In code, that same tiny mistake can bring the whole program to a screeching halt. The computer is super literal. It needs that grammar to be perfect.
Okay, so where do we keep all the information our program needs to remember? Well, we use variables, and the easiest way to think about a variable is just like a labeled box. You can give it a name, say player score, and then you can put something inside it, like the number 100, and later you can just find the box by its name and see what's in there, or even change it.
Now, of course, these boxes need to hold different kinds of stuff. You wouldn't store your name the same way you store your age. These different kinds of information are called data types. The big 3 you'll see everywhere are text, which programmers for some reason call strings, you've got numbers, and you've got simple true or false values, which are known as Booleans.
I love this quote because it humorously gets at a really important tool. This tool isn't for the computer at all. It's for us humans. They're called comments. Think of them like little sticky notes you leave for yourself inside the code. The computer just skips right over them, but they are absolutely essential for reminding your future self or telling another programmer what on earth a certain piece of code is trying to do.
Okay, so we've got our toolkit. We have the nouns of programming, things like variables and data. Now it's time for the verbs. These are the concepts that actually bring our code to life and, well, make things happen.
Meet the action heroes of your code, operators. These are just the simple symbols that let you perform actions. Some are for math, plus, minus, times, divide. Others are for making comparisons, like checking if one number is equal to another. These little symbols are the heart of every decision your program is going to make.
Now imagine you have a task that you need to do over and over again, like calculating a sales tax. Instead of writing out all the steps every single time, you can bundle them together into what's called a function. It's like a mini program or a recipe. You write the recipe once, give it a name, and then you can just call that name whenever you need it. It's a huge time saver. So how does a program actually think? How does it make decisions? It uses something called conditional logic, usually with if-else statements, and it works just like it sounds. You ask a question. If it's raining, then you tell the program to do one thing, like grab an umbrella. Else, meaning if it's not raining, you tell it to do something else, like wear sunglasses. This simple logic is behind every smart decision an app makes.
But what if you need to do something 1,000 times? Like check every file in a folder, or update the position of every enemy in a game. You're definitely not going to write the code 1,000 times. That's where loops come in. A loop is just a way to tell the computer, hey, repeat this block of code over and over until you're done.
It's the key to automation and one of the most powerful ideas in all of programming.
All right, you've gathered your tools, you've learned the actions. It's time for the payoff. We are going to combine all these ideas and write our very first real program.
So there's this time-honored tradition in the world of coding. It's like a rite of passage for every single new programmer. Your very first program isn't going to be some crazy, complicated app. No, it's a simple, beautiful little victory, just making the words, "Hello World," pop up on your screen.
And there it is. In a lot of programming languages, this one little line is all it takes. Let's look at what's happening using what we just learned. We're using a function. It's called print, and we're giving it one piece of information to work with, the string of text, "Hello World." And that's it. You've just told the computer what to do, and it did it. Seriously, congratulations. You're a programmer.
Seeing Hello World appear on that screen is a genuinely huge moment. You've officially finished the first chapter of your coding story. So, what's the last and maybe the most important step of all?
It's step number 13, and believe me, this one is the most important one.
The final step is just this: keep going. Practice these basic ideas. And listen, when you run into errors, and you absolutely will, don't think of them as failures. They're not. They're just little puzzles to solve. That whole process is called debugging, and it's a totally normal, everyday part of coding. The same curiosity that got you here, that's the engine that's going to keep you moving forward.
So you've done it. You've taken the first steps. You have the basic toolkit. You've written the very first chapter of your story as someone who creates things with code. And now, the only question left is the most exciting one of all. What are you going to build next?